Today I'm going to be going over half-life formulas. So here's the basic formula. Y sub 0 is the principal amount. Y is what you get after the decay occurs. And Y sub 0, our principal amount, times E to the power of the rate, which is the rate that it's decaying, and time, which is the amount of time that it takes in whatever units. So I have a super simple equation set up, just 1. So our principal amount is 1, and we know that the half-life of 1 would be 1/2, and we're looking for the amount of time that it takes for 1 to get to 1/2 based on this equation. So we're solving for t. First thing I'm going to do, because I see this e here, it's going to make it really difficult to solve. I'm going to get rid of it using natural logs, because we know that's the inverse. And so natural log of 1/2 equals natural log of e to the power of negative 0.5 times t. And then we know basic log rules that once these cancel out, or we'll be able to put these in front. So I'm not going to write that right now, but these cancel out in the next layer. We have negative 0.5 times t. Now we want to get t by itself, so we're going to divide by negative 0.5 on both sides. And then we're left with t equals natural log of 1/2 divided by negative 0.5. Now when we put that into our calculator, we get 1.386, but I know my calculator rounded, so I'm not gonna write it out because I know that's not the most accurate form. This is the most accurate form right here of the answer, and so if I were to put it back into the equation, I'll use that. One thing to look out for is making sure that you're using your parentheses correctly, and because if you don't, you can get a way different answer. And another thing is, if you know that you're looking for like the time or the rate or something, and you have the principal and it says half-life, you know that this is your principal, and this is just going to be half of your principal. It's going to be half of it, yeah. So for the next example, we have a mystery substance. I couldn't come up with a name, so we know the half-life is 2 days. So the t is equal to 2, and then our principal amount is 10 grams. So our y sub 0 is equal to 10. So I'm going to set up the equation, and I just said we're going to find the rate of decay. So we don't know what r is. So we have y sub 0, which is 10 times e to the power of r times 2. And then we're looking for the rate of decay, and we know it's the half-life. The y is just going to be half of 10, 5. Now another way we could set it up is just, again, 1 and 1/2. So we know if we divide 10 on both sides, we're just going to have 1/2. And that's just the first step that we're going to take. Now, same thing, it's the other side. We're going to take the natural log of both sides. And basic log rules, we pull this to the front. So we have natural log of 1/2 equals, these are canceled out, r times 2, or just divide by 2. And then we have r equals natural log of 1/2 over 2. Now again, my calculator gives a very like short answer, and I know it's got to go out further than that, so I'm just going to use this in my equation when I check it. So now that we have our rate of decay, we can plug this back into our equation just to check that we got it all right. So, and we're going to be using the actual units. So we've 5 equals 10 times e to the power of natural log 1/2 divided by 2 times 2. Now these will cancel out, so we'll have 5 equals 10 times e to the power of natural log 1/2. And e to the power of natural log 1/2 is 0.5. So 5 equals 10. 10 times 0.5. 5 equals 5. And so that all checks out. One way that this is useful in real life is just calculating actual half-life of substances. Once we get the rate, we can really plug in any day here, any amount of days, so we can basically use that to find out how much of a substance will be left, let's say after 4 days or 6 days or 10 days. So yeah, that's about it.